Welcome to Coach Actor Math. Today we will be talking about points, lines, and planes. Starting off at the top, a point is an exact location in space with indefinite size and shape. Whenever we represent a point, we always just put a little dot, and we're going to call this point B. Notice we always put a capital letter next to it, and that's how we name it. So to name it, we would call that point B, or since mathematicians are lazy, you'll often see them just denote it point B. Talking about a line is an object with no thickness that extends infinitively in both directions. Infinitively means forever in both directions. So we represent a line with what we typically consider a line. We also have to make sure that we have two arrows to denote that it goes on forever in both directions. When we have a line, the line must have 2 points to determine it. So we're going to call this line CD because it's the 2 points that it is going through. So when we name it, we are going to name it line CD, or we can name it line CD. Notice we put the arrows on the end to denote that it is a line. That will be important here in just a second when we talk about the line segment. Segment is just another way to say piece. A piece of a line that consists of 2 endpoints and all points in between. So I could take my line CD and I could cut it at point C, and I could cut it at point D, and I could have line segment CD. Notice no arrows means that it does not go on forever or infinitively. We would list that as segment CD. Or we could put a line CD. Notice on the line we put arrows to denote that it goes on forever. On the segment, I did not need to put endpoints. I just put a solid bar on top of CD, and that tells me that it is a line segment. A ray, often thought of as a sun ray, is a piece of a line consisting of one endpoint that extends infinitely in one direction. Now, just like a line and a line segment, we must have 2 points in order to name our ray. So I'm going to go ahead and use points F and point G, and I'm going to say that I have a ray FG. Notice I'm again using an arrow to show that it goes on forever in that direction. And when I go to name my ray, I'm going to call it ray FG. Or I'm going to put a ray on top. Notice no endpoint and an arrow on the right side, FG. Now what's important here is it doesn't matter if ray FG was going the other direction. We always name our ray with the first letter being the endpoint, and the ray is guided through G, but G is not an endpoint that stops my ray. My ray travels through G but does not end on it. So the first letter is always the end point of my ray. Opposite rays. 2 rays sharing the same endpoint and continuing infinitively in opposite directions. So 2 rays sharing the same endpoint. So we're going to say that they're going to share endpoint M. What's important about that is I can have a ray M N right here, known as ray M N, and I can have the ray M P on this side, known as ray M P. Notice both times my endpoint comes first. The other thing I want you to notice is because they were opposite rays, they were going in opposite directions, that creates a straight line. Now, I could name that line with any two of those 3 points, because with a line, it's not necessary to name a specific endpoint. A plane is a flat surface that extends infinitely in all directions. We have a hard time describing a plane in our world, but we always show it represented as a box, usually as a parallelogram. A lot of times you'll see a letter, like letter P, up there in cursive in the corner. That could be called plane P. Or, in order to name a plane, you have to have 3 points, like A, B, and C. Notice these 3 points cannot be collinear, otherwise known as non-collinear points. We will talk about that later. I could also call this plane A, B, C. Now, real-world examples of planes would be walls, extended forever, your desk, extended forever, or even just a piece of paper, extended on forever in every direction. So those are good examples of planes that you may see in your everyday life. The one way that we have not shown how to name a plane that we could still use would be to draw a parallelogram. That's a way that we say plane, and I could say it's plane P, or I could say it's plane A, B, C. So, it's talking about geometry basics. These are the basics. Points, lines, and planes are the 3 most fundamental pieces of geometry that we will talk about this school year, and it is important that we will build everything off of those points, lines, and planes. Flipping over on the back, talking about collinear. Looking at collinear points, those are points that lie on the same line. We've already talked about some collinear points. If you remember, we've already talked about the opposite rays, MN and MP. So right now I could say that points P, point M, and point N not only make 2 opposite rays, a pair of opposite rays, but point M, point N, and point P are collinear. Notice, co means together, and linear has the word line, together on a line. Non-collinear. Well, now all we've said is together on a line and added the word non. Another way to think about non is the word not collinear. So 3 points that are not collinear. If I go ahead and draw P and M in my line, if I were to add a point Q off to the side, point P, point M, and point Q are non-collinear. Coplanar. Very similar to collinear, the word co appears, which means they are together, and the word plane shows up. They are points that lie on the same plane. Remember that we often show this with a plane, and then we go ahead and draw points like A, B, and C, and I can say point A, point B, and point C are coplanar. Non-collinear points. Again, the word non is not coplanar. So we often denote this with a plane with points like A, B, and C. And then we put a point R outside the plane, and I would say that points A and point R are non-coplanar. At this point, I challenge you to pause the video and go ahead and fill in the bottom part, naming each one of the following from the picture at the right. Do the best you can, and when you are finished, unpause the video and check your answers. All right, looking at number 1, naming the points. All the points that exist, we've got point A, we've got point B, we've got point C, we've got point D, point E, and we've got point F. Looking at the lines, there's only one line. However, I could name it line AD, or I could name it line AE, or line DE, or line ED. Any of those above would work. We're going to take 2 points off of my line, and I'm going to use those to name it. Order does not matter with a line. Looking at my 2 planes, I'm going to look at this first plane that comes at me. Notice there's a G up in the corner. I could use the letter G and just call it plane G. But since there are 3 points on there, I'm going to go ahead and call it plane D, E, F. I could have also called it plane G. So looking at the other plane that we have here, notice an H up in the top. D and E are still on that plane because those 2 planes intersect at the line. But C is my 3rd point this time. In this case, I'm going to go ahead and just name it plane H. A little bit simpler because I've named it based on the italic letter that shows up in the corner. Line segments. I have multiple line segments here. I can talk about segment AD, and I can talk about segment DE. Again, I could call it segment AD or segment DA. Either one is acceptable as there is no order necessary for a line segment. Rays must be in a special order. Specifically, I must have my endpoint first. So I could say that I have ray DA. I could say that I have a ray EA. I could say that I have a ray DE. Or I could say that I have a ray AE. In this case, I want a pair of opposite rays. Notice I had 2 rays with the same endpoint. I would say that the opposite rays are DA and DE. Because if I put them back to back, they create a line. Thank you for watching, and I hope this was informative. This is the end of our lesson on points, lines, and planes.